For example, since our first color since our color 1 is defined as 111, this is the white polar cap. So that means the first index item is 1, okay, and then the second index item is 1, and then the third index item is 1. So this is the first indexed item, the second indexed item, and then the third indexed item corresponding to index 0, 1, and 2. Now, given that the corresponding values for color change have been calculated before as this one here for the R, the negative 0.013 repeating, and this one here, I'm underlining it, negative 0.013 repeating for the G, and 0 here for the B. Then what are the colors for the first few lines? Okay, the first line, actually, it's a given. It's a white. This is the polar tip of the Earth. And then what is the second line? It's still 111. Why? Because the count is 0. This happens within the first reading of the loop. So the count is still 0. Look here. If the count is 0, I'm underlining it on the upper portion of the screen. You multiply 0 to whatever color change here is, it becomes 0. And when you add the 0 to the original index item for color 1, then whatever index item is there, it is the value of the R. So there is no change for the R, the G, and the B for the second line here because the count is 0. Now on second reading of the loop, the count is now 1. So the values of the RGB supposedly will change. What is the new R? The new R is equal to, as we have in the formula up here, the new R is equal to the first index item for color 1, which is 1, plus color change first index item, which is negative 0.013 repeating, times 1. Look at the result here. It's no longer 1. It is 0.986 repeating. Now, what is the new G? I'm using the formula for new G up here in the upper portion of the screen. 1 is the second index item per color 1. Note the index is 1. And then negative 0.1, negative 0.013 repeating is the color change index 1. And the count now is 1. And look, our new G is no longer 1, but it is 0.986 bar. But what is our new B? What is our new B? Since look, the color change for B is 0, so there will be no change in the value of B as we go from the upper tip of the planet to the equator. So look at this. 1 here, I'm underlining it, is the second, is the third index item per color 1. And then 0 is the third index item per color change. We multiply that by 1. The answer is still 1. So look, for the third line, this is not pure white, but it is very close to white. Let's go to the fourth line here. For the fourth line, our count now is 2. And what is our new R here? Using the formula on the upper portion of the screen, new R is equal to the first index item for color 1, which is 1, multiplied by the first index item in color change, which is negative 0.13, repeating, multiplied by the count here, which is no longer 1, and see what the new result is. It is 0.973 repeating. It's exactly the same as the new G. So we have 1 plus negative 0.013 repeating, multiplied by the 2, it is 0.973 repeating. But yes, as I mentioned a while ago, since the color change value for the blue is 0, the blue value 1 will not change as we go down the line. And what do we have for the equator here? Incidentally, this is the color for the fourth line. It is no longer the same as the color for the third line, but this is still not very different from white. You know that we are smoothly transitioning from white to blue. And what do we have for the equator line? When we apply this formula here above, it will become 0, 0, 1, which is blue. Actually, this is our definition for color 2. This is our target color for the upper half of the earth. It is 0, 0, 1.